Hello, everyone. Let's get started with our first joint session here. Session 2A, Characterizing Air Quality in the Gulf Coast region. Thank you all for attending. Our first speaker is Doug Boyer from the Texas Commission on Environmental Air Quality. We'll be discussing coastal air quality research for regulatory applications. Danny will pull up your slides. You have 10 minutes. How are we?
10 minutes, all right.
Yeah, and we'll have about a half hour, hopefully, for discussion at the end.
Yep. Okay, thanks for having me. I really appreciate the opportunity to be here. I'm going to talk about the TCQ's involvement basically in air quality research and sort of tie it into the regulatory applications that we have as a state agency. So I want to sort of touch on two main points here that we've been looking at. And so we're required to use different regulatory models when we're doing attainment demonstration modeling. And those are required by EPA. So CAMX, CMAQ, they're similar photochemical models that are used in this air quality community, similar to like WRF-Chem or GEOS-Chem. But these are the two that we're required to use. And so I have a couple things I want to talk about in terms of challenges and how we can help address that and talk about it today. And so one of them is about offshore ozone production. And with our regulatory models, we've seen this in the past a lot, where we're having a lot of ozone being produced in our photochemical models offshore. The simulation there on the left is from TCQ's CAMX modeling, and the image on the right is from LADCO, or the Lake Michigan Air Directors Consortium. Both are CAMX modeling. We've seen this in CMAQ as well. And so in terms of ozone being produced offshore, you know, we're thinking about the health impacts of that. Well, there's no one out there really, maybe some folks on offshore rigs and things, but the unique meteorology in these coastal areas can bring some of this ozone pollution into our areas of concern. And so in Texas, Houston is a non-attainment area for ozone. And in this simulation, we have sort of a stalled frontal system, and behind it, we're having some north winds blowing some emissions and generating ozone offshore. And then that can come back onto Houston and Louisiana. And so we're seeing this. We don't know how well our models are doing. In past field studies, we've seen that this is probably overestimated. Similar things can happen in the Great Lakes area, Northeast. And so we're trying to understand this. It's a very difficult coastal area to model in terms of meteorology. The vertical mixing is very challenging. And so trying to use all the tools that we can to help us understand this better is sort of one of the things I want to think about. And there's a lot of non-attainment areas in coastal areas as well. And so this isn't just a Gulf Coast issue. These are the non-attainment areas for the 2015 ozone standard. And there's a lot of them in these coastal areas that have these similar challenges, especially when we're talking about modeling them. It's also important in terms of the regulatory aspect, and EPA has noted the challenges, especially in the meteorological aspect of it. In their recent, in some of the regulatory applications, they have chosen to remove some of these water cells when we have to calculate a future design value, looking what's going to happen in the future in terms of ozone or PM. They've decided to take out some of these cells that are strictly just water-based because of performance issues. And so this can have an impact in terms of what the future design value, the regulatory impacts of transport, or just attainment decisions. And so being able to model these situations in a more refined way, I think is going to help everyone in the end. So hopefully we'll have some discussion about this later. So in Texas, we've been trying to help address this and understand it a little bit better. And in this past year, we had the Tracer AQ campaign in the Houston area. And so we were very lucky to collaborate with a lot of folks, including NASA, the University of Houston, Baylor, St. Ed's, and many other groups as well. And so NASA came with their G5 and their downward looking remote sensing instruments. We had ozone LiDARs that were ground-based looking up, and then we instrumented some boats as well, trying to understand this, the importance of air quality offshore and trying to measure it in more detail. So I just wanted to show a couple of, some initial results, and Travis Griggs is here, and a lot of the work from University of Houston is from him. So they had instrumented a pontoon boat from the University of Houston that's shown on the left, and then they had a commercial service boat on the right that had ozone instrumentation and meteorological instrumentation as well. And so this just shows the tracks that had happened all last year. And we were able to observe times when ozone concentrations were elevated, and times, and we had also forecasted that as well. And so we have a whole lot of data. We're excited to start diving into that. We have some analysis projects upcoming to help look at this data a little bit more. And in 2022, this summer, we're going to continue these type of measurements. We're calling it Tracer AQ2, and expanding a little bit with adding another commercial service boat that's going to go up more into the Houston ship channel. So a lot more work to come. Also wanted to say that we're trying to understand more about the vertical aspect of air quality as well. We spent a lot of resources on ozone sondes last year. We had 96 ozone sondes in the Houston area, a lot of them offshore as well, and one there on the commercial service boat is shown. So Paul Walter at St. Ed's did a lot of this work, and we're going to continue that this upcoming summer. But trying to understand the mixed layer, basically right at the coastal interfaces offshore, and trying to see how well our measurements are doing, and then comparing it to models. And so just some last thoughts here in terms of future research and analysis, and where we could have further discussions of where we could go here. And so one I just wanted to bring up is trying to coordinate some of these field studies. We have them like the Lake Michigan ozone study, the Long Island Sound tropospheric ozone study, Tracer AQ. We have these in different areas of the country with a lot of measurements, a lot in these coastal areas. Can we combine these to help us get a better picture of what's going on, inform our models, inform our understanding of this air quality and the formation of it that can then come into the regulatory community. We have some TC co-funded analyses that we're doing. One is wharf configurations, trying to understand and improve our replication of the meteorology. And so looking at Tracer AQ timeframe and looking at different wharf configurations to see how we can best simulate that. Like I mentioned, vertical mixing, I think, is an important thing to really investigate more. We had some really unique observations of residual layers of ozone and PM during Tracer AQ, and trying to understand how those are mixing and then impacting our areas and our non-attainment, and how does that then go into things like contribution analyses and transport analyses. Chemistry, we've done some work in the past in terms of trying to understand how well our models are doing, and thinking that they're over simulating ozone formation, and part of that was perhaps due our underrepresentation of halogen chemistry. And so looking at some of the green paper analyses and things with tempo, it seems like there might be some observations that would be beneficial. And so we're excited to see about that, of bromine oxide or iodine. I've always been interested in marine isoprene, and I've talked to Dana Tong about that a number of times. So maybe we can get some observations of that through satellite analyses that can then be input into our models as well. And then emissions, and we're always trying to improve our emission estimates, especially in these coastal environments of commercial marine vessels and offshore platforms. So that's sort of what I had to share, and look forward to this participation and collaboration today, and appreciate your time.
Thank you very much, Doug. We'll have questions at the very end and within the 30-minute Q&A. So next presentation will be remotely, and it will be also joint. So while Jenny gets started on that, there's a few muting and unmuting that needs to happen. So I'll just quickly introduce them. Holli Ensz from the Bureau of Ocean Energy Management, and Ryan Stauffer from NASA Goddard will be jointly speaking on the NASA BOEM Interagency Partnership to monitor oil and gas emissions over the Gulf of Mexico. Holli and Ryan, are you there? Can you hear us?
Hold on a second.
Can we hear you?
So we have to mute our.
Hi, this is Holly. Can you hear me?
Holly, I can hear you.
Oh, great. I don't know if the room can hear us though.
Yeah, I think they probably can. There's some things they have to do with the muting in the room, so I think you're good to go. Yeah.
Great. My name is Holly Weck. I was introduced as Holli Ensz. I recently got married. My new name is Holli Weck. Bureau of Ocean Energy Management. It's a branch of Department of Interior. And Ryan Stauffer will be talking in a little bit from NASA. He's the PI. Recently, we completed a interagency agreement between BOEM and NASA. And so we're going to discuss that past interagency agreement and also future interagency agreement that we have in works. This interagency agreement was a partnership to monitor oil and gas emissions over the Gulf of Mexico region. Next slide, please. So you might be wondering, why is Department of Interior interested in air quality and emissions offshore? There's actually two reasons for that in the Gulf of Mexico region. Believe it or not, BOEM has air quality jurisdiction in federal waters on the OCS, Outer Continental Shelf, in the Gulf of Mexico region, west at 87.5 degrees longitude. So basically, if you look at the map and you draw a line south of the Florida, Alabama border, and anything west of that, BOEM in federal waters has air quality jurisdiction, not EPA. And that's under the OSLA, the Outer Continental Shelf Lands Act, gives us that authority. Also, the Clean Air Act gives us that authority. And the recently, I guess in 2012, we got air quality jurisdiction in Alaska in the Beaufort and Chukchi Seas. Our regulations are promulgated at 30 CFR Part 550.303. As part of our regulations, we have a monitoring effort. And when we say monitoring, we mean emissions inventory, EPA type emissions inventory, a bottom up, where the operators provide us activity data and we multiply it with emission factors, EPA approved emission factors from AP 42, and come up with an emission inventory. So this map is an emission inventory of all the NOx emissions in the Gulf of Mexico region for 2017. And these are just the platform sources. We also have an inventory for the non-platform sources, which includes the support vessels, the pipeline vessels, etc. Next slide. Ryan?
Okay, thanks, Holly. So, of course, one of the challenges with trying to monitor air quality over the water, and Doug touched on this a little bit in his talk, is that there really are no in situ monitors that BOA can use as a data source to really evaluate their emissions inventories and also to track air quality and its evolution over the Gulf of Mexico around these oil and natural gas operations. So basically, BOEM came to NASA, and we started an interagency agreement that was for 3 years, and that was actually the principal investigator with that. For that agreement was HAQAST member Brian Duncan. And so The upshot is that this interagency agreement looked at the feasibility of monitoring Gulf of Mexico air pollution. And we're primarily looking at NO2 here from oil and natural gas operations with existing satellite measurements, for example, BOEM. So one example of using satellite data to monitor air quality over the Gulf of Mexico is shown on the top here. And on the top right, you can see out in the deep waters there, these platforms, they each have names. So there's Mars and Olympus, and there's the Brutus platform, and you can use SUMI MPP VIIRS instrument to look at flares, for example. And then the following day, this is from a case in January of 2019, we can see enhanced NO2 values in the troposphere as measured by the BOEM instrument. That was a result of this flaring activity. So that, I think, was promising for us to see that in terms of understanding what we can actually do with satellite measurements to track air quality over the Gulf of Mexico. And then also as part of this interagency agreement, the agreement really culminated in what we call the scope cruise, which I believe I presented at HAQAST before on this. That's the Satellite Coastal and Oceanic Atmospheric Pollution Experiment. It was a 9-day cruise in the Gulf of Mexico to evaluate satellite measurements with the ground-based Pandora spectrometer, so looking directly at the sun to get measurements of the column amount of NO2 as well as other trace gases, and also using in situ sampling during this May 2019 cruise. So you can see on the bottom is the track of the ship in the black line, and then the colors represent the Pandora total column NO2 with the red colors indicating higher amounts of pollution, which we found near the coast toward the second half of the cruise. And then just for reference, the dots represent, I think it's the top 250 emitters in the platform NOx emissions inventory, just for reference. So the next slide, please. So in general, this scope cruise, as part of seeing, testing the feasibility of using satellite measurements to measure air quality over the Gulf of Mexico, we really wanted to evaluate the accuracy of those satellite NO2 measurements. And we did that with the Pandora spectrometer during the ship cruise, as well as along the coast. We had more Pandora instruments set up at the port that we left from in coastal Louisiana. So you can see our evaluation of the Pandora total column NO2 on the x-axis there. And then on the y-axis is the satellite total column NO2, either from OMI or TROPOMI, and there are different versions of the data here, but basically all you need to take away from this is that during most of the cruise and most of the time that we were down there in May of 2019, is that the NO2 between the satellite and the Pandora ground-based instruments agreed quite well, typically within about 5%. There is one exception, and that's circled toward the center right of this figure. We encountered some moderate pollution over the Gulf of Mexico, actually, on a few days toward the end of the cruise. And that's when actually OMI and TROPOMI measured about 15% or so low compared to the Pandora total column NO2. But I'd say in general, we've evaluated the quality of the satellite NO2 measurements and found them to be quite good compared to ground-based measurements. And another thing we learned from this cruise is that the continental sources really outweighed the effects of the oil and natural gas emissions in terms of air pollution emissions in the Gulf of Mexico. For example, halfway through the cruise, the winds shifted from onshore, bringing clean air, to offshore, when suddenly at the ship we experienced a lot of continental air sources and air pollution, and the NO2 column amounts essentially doubled when that wind shift occurred. Again, telling us that the continental sources are really the major player in the Gulf of Mexico. Next slide, please. And so Holly mentioned that we are finishing up a second interagency agreement on finalizing that, which will be over the course of 5 years. And of course, the great and exciting thing about monitoring air quality over the Gulf from the platforms will be the tempo instrument, which you can see an example of what the measurements might look like on the top right there. So that's a really exciting factor for us in a new satellite instrument, which we can use with the additional hourly measurements rather than once a day to see how air quality evolves over some of these oil and natural gas regions. And then one aspect that BOEM is really focusing on for this interagency agreement also is looking at greenhouse gas emissions from the platform sources. So another thing that we encountered during the scope cruise in May of 2019 is that we found numerous methane leaks in the shallow water platforms, which typically have older infrastructures than some of the deep water platforms. So on the top left, you can see an example from our cruise on the 16th of May, when we encountered a huge methane spike of over 16 parts per million, which is about 8 times the background of what we typically would find. And you can even see on the graph there a couple other wiggles. So essentially, anytime we pass one of these platforms, there was a spike in methane. And so that's something that we'll also be focusing on a little bit with this interagency agreement that actually is a little bit larger in scope than, well, not to use a pun for our cruise, but larger in scale than our previous interagency agreement. Next slide, please. And so this agreement will be with NASA headquarters, not with NASA Goddard, as was the case with the past interagency agreement. So in addition to looking into doing another scope cruise, which we currently have planned for mid-June of 2023, we will also be looking to coordinate with aircraft measurements. Doug mentioned for TracerAQ, the GCAST GeoCape Airborne Simulator, which gets column measurements of NO2 from the aircraft. And we're also looking into the possibility of carbon mapper flights to look at methane over water from some of these sources. And so as part of TracerAQ last year in the Houston area, we had a 27th of September GCAST flight over some of the deep water platforms that really demonstrated the instrument's ability to look at NO2 plumes from some of these deep water platforms. So in this case, the figure shows the platform called the Jack St. Malo out in really the middle of nowhere in the Gulf of Mexico that has a pretty significant NO2 plume coming from, it's really a point source that you can see from the GCAST measurements. And the plume really follows the mean wind direction coming off of the platform as well. So that was also, I think, encouraging to see that we should be able to use ground-based measurements, the aircraft measurements, and OMI, tropomi, and tempo to really get a good view at what NO2 emissions and the NO2 inventory really looks like over the Gulf of Mexico. And next slide. And I think this is just, so this is just really the overarching goal to really evaluate BOEM's emissions inventory with various data sources, not just satellite data, but also aircraft and in situ and ground-based remote sensors as well. So I think that's all we have. And thank you for your time.
Okay, I've been given the go-ahead. Hopefully you can hear us. Congratulations to Holly on your recent marriage. Good, an excellent presentation. We'll circle back at the end once we get there. Sorry, I got to bring in the next title. Ted Russell will be speaking next. Impact of airport, seaport, Railyard emissions and air quality, exposure, and health. Thanks.
Very good, thanks. And what I thought I'd just talk about today is what our HAQAST project, this is our main HAQAST project, is all about, where we've been assessing the impact of ports on air quality and health, et cetera, around in various areas around the country is the plan. And one of the questions might be is that why would this be in the about the coastal or the Gulf Coast air quality impacts? And one of the things you'll see is we're looking at ports that might be impacting Houston, and we've talked with people in Houston about doing this sort of work here as well. So what we're going to be looking at is how these ports impact exposures around them. And by ports here, we take a broader meaning. It can be shipping ports, it can be airports, and it can be railroad switch yards, all of which can lead to essentially intensified emissions in that area and increased exposures. And many of the times these are in vulnerable communities. So what we found is that you can actually use these satellite capabilities to provide spatial detail and sort of some additional analysis that you just additional observations that you just can't get from some fixed sites, just number, you've been hearing about that, et cetera. And in particular, I'm going to talk about some of the work we're looking at with NO2. And one of the things that we do is to integrate the satellite observations with the air quality modeling that we've been doing for who knows how long at this point. And the reason why we do it is to actually link, one of the reasons is to link the NO2 that you can observe very well by satellite. We've heard a lot about that. It's truly exciting, with ozone, which is not as well observed, and also to look at secondary aerosol formation. And you can all do this with this integrated approach. So in particular, just looking at the example in Atlanta, where we've been using the fine scale tropomi NO2 retrievals to characterize a number of sources. The one you see here is we've been looking both at the Atlanta airport as well as some power plants. But in particular, we're focused more on the airport because we have some low SES communities around it. And what you can see is, and this is something that sort of blows some people away at first, is that that blob of high ozone or high NO2 is actually down around the airport. It's not right around, and so is this showing? Yeah, that's downtown. Oh, too bad. Atlanta is north of that, and that's where essentially 3 freeways crosses down in downtown LA. But you see that the concentrated NO2 is down at the airport due to the ground-based operations as well as the aircraft, obviously. And so you see this intense area. And so what we've done is linked those NO2 observations to ozone formation from the airport operations, et cetera. We compare how well the CMAQ compares with the NO2 vertical column densities. And they actually compare quite well. And actually, that's one of the nice things is through this, we've actually really been able to find a very good comparison between them. After doing that a lot in Atlanta, we're not done yet. We're working with a local school to further investigate some of the air quality issues, in particular, how the airport is impacting ultrafine particles. Well, we've now started looking at Los Angeles, and in particular, LA and Long Beach are 2 of the largest US shipping ports. And we're going to look at this just in terms of the long-term impact, but something came up essentially last fall with the concerns about the increased shipping around Los Angeles, essentially the increased operations there, that might be adversely impacting air quality in the port area. And so we looked at that specifically, but we're also looking at the long-term impacts of the port operations in Los Angeles as well, with a particular eye at how well do the policies aimed at reducing emissions in that area impact air quality. So what I'm going to show is that we've looked at how the emissions impact and the emission changes have impacted air quality for a pre-COVID period, as well as this period when there was increased shipping emissions in the area, just to see if we can see this. And this is sort of a neat, and it actually sort of works out, I think, simulation that's from CNN that shows you the difference in shipping operations between 2019 and 2021, and why you could be concerned about all this increased shipping. And there's also an increase by about 5–10% in both the trucking and rail associated with the ports, with 2019 on your left, 2021 on your right, while they had all these ships sitting off the coast. And you can really see there is quite a bit more activity in 2021. And so when we looked at that in terms of the air quality, this is where we compared tropomi and CMAQ, and things look really rather in pretty good shape. There are some differences which are plotted. There's the difference plot right there, where you do indeed see that CMAQ is overestimating NO2 downwind, or downtown, not downwind, but downtown. but there's general agreement. And I'll just say that there's a reason why that we think CMAQ is high downtown, and it doesn't have to do totally with a problem with the emission inventory. So what we did using the CMAQ modeling was essentially use that to remove the impact of the meteorology between that you need to do to assess how trope only would lead to an assessment of how emissions have changed over time. And that's what you see on the left, is that this is the met-adjusted impact of emission changes from trope only between 2018 and 2019. And this is what you would get when just looking at what CMAQ provides. And what you see, and I think this is the important things, is that the trope only retrievals suggest a larger decrease in the NO2 columns, sort of in this corridor going up from the ports into downtown LA and north and somewhat along the freeways. You do see some increase if you look right there. I'm not too good with a mouse on something like this, that do appear to be associated with the increased shipping. But you also see this increase all over Orange County, which is somewhat downwind, but I suspect there's going to be other reasons for that we're looking into right now. But one thing that did suggest is that the emission controls are indeed beneficially reducing NO2 over this part of Los Angeles. We've actually looked at the traffic counts, and by this point, the traffic counts were coming right back up, and we're looking at that in more detail as well. But fundamentally, it's really that the trope-only retrievals do indicate somewhat greater changes in NOx over time. And we've tried to adjust for meteorology in a couple of different ways, and it's pretty consistent that we see this. So I think that she really shows you one of the powers of the satellite retrievals is that, you know, the modeling only can get you so far because we're sort of tied to these emission inventories in the end. But the other thing, just the agreement that we saw on the first slide, there is general agreement, but we have to come up with better and more advanced ways to really dig into this in more detail. So this is a summary. That's what we've been doing, is we've been integrating the use of the air quality models and the satellite retrievals applications in Atlanta and LA so far. One of the things we're looking to do is, you know, probably a different port per year. We've talked to people from Houston, Chicago, about what we might look at in those locations. And so we are, you know, we're open to those discussions. And we are going to be contributing to looking at warehouse impacts as well. As just another very small port, I guess, is the way you might look at it. So thank you very much.
Thank you, Ted. Very nice presentation. And finally, wrapping up this session, Amber Soja will be discussing quantifying burned areas for emissions, air quality, and health.
Hi there. Can you hear me okay? All right, good. So I have both a PI-led project and I also have a Tiger Team project. And the point of this slide and my next slide is just to show you that we're not working alone. We're trying to reach out to anyone that we can. And that's the point of these two slides. So the Tiger Team is led by Cheryl Maximum, and I'm kind of a co-lead, an assistant. And she has a large team of people as well. So we're trying to reach out to all our stakeholders. And like Tracy says, we're trying to make more when we sum up all our parts and make this a little bit bigger. I think we're doing a pretty good job with that. So what I'm going to do right now is I'm going to talk really quickly about some of our results, our initial results from the Tiger Team and from the project, and how we're trying to put these together so that we get more from each other. And it's kind of an exciting time. Next year will be even better when we share results. So we all know that smoke affects health and air quality. This has been shown. And even though there's some controversy in the differences, we know that smoke is really bad for our health, heart attacks, cancer, death. It's nasty stuff. We know that. But we also know that climate is changing, fire is on our landscape, and we have to have fire on our landscape. So we need to learn to live with fire on our landscape. So it's this balance. But how can we make a balanced decision if we don't have the data? And quite often I hear, well, there's no burning in the Southeast. And I'm like, oh, just because the satellites aren't overhead doesn't mean there's no burning in the Southeast. And I've seen that written, and actually I've been turned down for proposals because they'll say there's no burning in the Southeast. It's all out west. Why are you arguing this? Like this person has no idea what they're talking about. So finally, something was selected here, and I get to really show there is burning in the Southeast. You believed me. But it's not only the horizontal, it's the vertical. It's the vertical aspect of smoke. And so this in the bottom panel is a picture of Calypso data. And because it's often cloudy in the Flint Hills, these are actually hard to find. But so we need to find a way through purple air and air now and through LiDAR in order to figure out what is the vertical extent of aerosols, because it's where we're breathing that really matters. As part of this HAQAST Tiger team, what's really neat about this is on the left-hand side, you see satellite data, but it's not only satellite data, we're adding ground-based sensors. So Cheryl has a team largely made up of students and postdocs, and they have put air quality sensors out in the Flint Hills, and they're about ready to come back home. And in the bottom panel, you can see that when the dates for both the Flint Hills and for Florida. So these are the times the purple air sensors will come back. So we're about ready to collect the data and put it together with satellite data. So it's really an exciting time. And that's when I said, well, I said, this will be better next year because we'll have lots of good answers and assessments. So that's an exciting part of this. So what we can do with satellite data, there's all types of air quality and AOD and lots of different data. But what we have done so far is we're able to see about how much area is burned by a MODIS burned area product, but also how much is detected. And we're asking questions, well, how much can we really see from space? Because again, if we don't get this right, then we don't get the inputs to CMAQ right. And we can't balance our equation and what it means to health. So having something on the ground where you're breathing and satellite data and seeing how much we're missing and the models, this is the way we're pulling it all together. So this is where we've looked right now. The air sensors the purple air sensors are out, about to be pulled back. And MODIS is shown in the top, MODIS burned area. On the bottom is the fire detections. So in the Flint Hills, the burning was in April. That's the peak. And it's not that extensive. And this is consistent every year. You can see it in the yellow in the burned area product. However, if you're looking at the burning in Florida, it's a lot different. It's more extensive. It's over several months. And this is when the sensors will be pushed out. And there's a time that there's clean air sensed before and after the season, so on the shoulder seasons. The top again is burned area by month, MODIS product, and fire detections at the bottom. So we're completely consistent. And if you note, if we looked at the cropland data layer, the CDL on the bottom left. So according to the cropland data layer, about half of the area in that region is burned every year. But we have a feeling it's more than that because they're small fields or hard to detect and when sensors are overhead. So what we're doing to look at this is we're actually getting in there. We're using the Planet commercial data that John spoke about, and we're digitizing. So we're hand digitizing when we find these fields. And then we're going to compare these data to the satellite data to ask the question, what can we really see? And we're definitely in touch with the EPA and the people that are George Pulio and people that are actually putting together the fire national emissions inventory. And working together. So also we're leveraging off of NASA field campaigns. FireXAQ was an air quality field campaign that detected fires, and it's a flying laboratory. The DC-8 is a flying laboratory. So it was NASA NOAA campaign, and they have all these instruments on the plane, and they focused on out west and the east. So they did prescription fires and that we had set. And so these were real planned and instrumented fires, and also agricultural burns, pile burns, all kind of burning. And the DC-8, even though it's huge, was able to get down and fly into the smoke and sense it and detect it and and detect all the chemical constituents as it transforms and moves through time. So it's a host of data that is free and you can use it. So what we did with this data, this is one flight track from one day, as we looked at the data, and we're looking at not only the commercial data to detect what we can and can't see, so we've quantified some of this. So MODIS has been our workhouse, but as you can see for this one day, only 36% of the fires we flew, and we are using satellite data to find the fires. So when you get in the region and farmers, when they're burning, when their neighbor's burning, they're gonna burn because it's a good time to burn. So MODIS detected 36%, FAIRS 55%, and GOES 73%. And we were very liberal with our criteria. If we become more narrow, that relationship doesn't hold, it becomes less. But GOES, even though it's 2 kilometers and isn't always spatially accurate, it's a really good 5-minute instrument to get diurnal cycles. So here's a little more detail. So on the left-hand side, we're looking, this is burning in a grassland that we had set. So it was a planned burn. And we had some awesome partners in Kansas. And on the left-hand side, you can see in the orange, it is VIIRS detections. On the left-hand side, the big round pink thing is GOES detections, but they're on top of each other. So they're all in the same place. So we have many of those. And on the left-hand side, there's actually only one MODIS detection shown in the yellow. So this is the post-burn. And on the right-hand side is the pre-burn and the post-burn, and Planet or Sentinel data, we use both. And so you can see that we've digitized this area, and you can see that if you look at it really quickly, you can easily find the burned areas in these data. This is a pretty large area burned. So if we put this all together, MODIS captures only 16% of the fires detected, VIIRS 46%, and GOES 63%. And we did use a very liberal criteria. Probably, or when we publish it, we're going to be more realistic as well as liberal to assess how much burned and how much we can actually detect from space. And the reason for this is the polar orbiters, VIIRS and MODIS, have 2 of each. As they go around at certain times, and farmers get up early in the morning, and prescription fire people, the temperature is low, the humidity is high. They don't want their fires to get out of control. They want to burn what they want to burn. So they're going to burn early and late. Satellites aren't overhead with the polar orbiters. So that's why GOES, even though it's a larger footprint, it can see more of the small fires, which doesn't really make sense at first, but that's what's happening with this. So we've also digitized these fields and compared burn areas. We've established relationships. We're not done, even though the relationships aren't good. It's better to have relationships than to not have relationships, so that you know how much of what you think burned and how much more might have burned. And so that we're starting to look at both of these, both the detections and the burned area with all the satellites to figure out just what we can see out there. So this is pretty much my last slide. I have a conclusion slide, but I just wanted to say that I just came back from a fire and climate conference last week, and I feel even more motivated than I was the week before. And what we have to worry about now is really climate change, and climate change as it relates to air quality and health. And I'm just focused on fire, but I mean that in the broader sense. But for me, fire, we have fuels all over our landscape. It's building up. You're talking about the east, you're talking about the west, it doesn't matter. If you're talking about the Flint Hills, the fuels are building up. And people are sensitive to smoke in the air, and they're sensitive to air quality, as they should be, but we need to balance it, because when these fuels build up so much, then they're going to burn at an uncontrolled rate. Flora will not choose for the flora and fauna, the plants and animals that we want on the landscape. People's cows that they have kept for generations, not only of the cows, but of the people. The people have built this community of cows or pigs or whatever they're doing, and they have looked at this genetics for years, I mean, their grandfathers and their great grandfathers, and to have them all burnt, and you're close to your animals. So it's just horrible. It's horrible happening when we allow things to get out of control. And I'm not going to talk so much about it west, because you've heard about it. I mean, California, Colorado are all in the news. And we're going to have to learn to live with fire on our landscape again. And I have no illusions. It's not going to be easy. We don't have the infrastructure, like, or the people or the money to burn. We don't always have support because people aren't comfortable burning right next to their houses, but we're going to have to learn to live with fire again. And if you show examples of people that have burned near their houses and across their landscapes and in the Flint Hills, and compared to somebody who had a wildland fire that burns at the 80-90 percentile of fire weather, as opposed to the chosen ones at 50-70 percentile, the difference is amazing. So part of what we can do socially is promote this and let people see these differences. And if they see the differences, they want to be the people that have prescription fire near their house. And this has worked in several examples, and we just need to sell this a little bit further. We need prescription fire on our landscape. And relative to air quality, we don't even know the differences of the health effects between persistent fire or extreme events that happen less often. So I'm just saying we need to have the data and the tools in order to make the right decisions. And that is basically what I have. We need to work together as a community. And thank you.
Thank you, Amber. Lots to think about at the end there. So actually, you don't have to sit down. I think we're going to come back up. Two other speakers, Ted. And, oh, sorry, they're remote. That's
So how do
fine.
you want to, are they going to be able to join remotely?
They're on, I can try and display them. And if they, I told them in the chat, if they want to speak, they have to message me so we can turn this on and turn the audio off so it doesn't get feedback.
Okay, so first, any questions from the audience for any of the speakers? Yes.
Yeah, so, and this is for Amber. I recently spoke at a Master Naturalist group in Round Top, Texas. And another speaker from that group talked about a prescribed burn that he had on his property and went through the whole procedure of how that worked. And it was pretty extensive, the precautions they took. I'm wondering if publicizing that might help the acceptance of prescribed burn.
I think that's one of the many things we need to publicize. And the other thing is some are going to get out of control. I mean, they are going to break the prescription. They're going to get out. But it's far less than the numerous fires that we're hearing about now. But that's a great idea. Now, I mean, ways that we can make this comfortable, because politicians are now making decisions like right now the Forest Service can't burn, but it's a good time not to burn because it's hot. But so they have a moratorium on prescription fire right now. They are not allowed to do prescription fires at a local level on the landscape because politicians have fear, because local people have fear. So we need to start changing the way we think, because you can pay me now or you can pay me lots more later. So that's one good example of what we could do, and just advertising what prescription fires do to take the fuels off the landscape. So if there is a fire, it's not as bad. You don't lose your plants, your animals, and you can choose for what you want, the ecology on your landscape. So the prescription is to manage, you always control the fire, it's always controlled, but you manage for what you want on the landscape and burning the fuel so that we have what we want on the landscape. It's just, our fuels are out of control right now.
Yeah, he went into detail exactly what they do to make sure it stays contained, or at least to maximize those chances.
Yes.
He had never done one before, so it put his own fears at ease.
Well, he sounds like a great person to give examples. And in the Southeast, because there's been more prescription fires, there's organizations like Tall Timbers that actually burn on private lands and teach people to burn on private lands. So there are lots of good examples that are burning near cities, and people have examples as well, burn bosses. So much so, there was one that I heard about, Steve Miller. He even has a little, it's a YouTube video now. It's like how to bring prescription fire back to a landscape and have the community say thank you. And it was $1 million homes mixed with townhouses. And at first they're like, they're not burning here. And then after a while, they're like, wait a minute, you burned over there, you haven't burned mine in 2 years. When are you gonna come back and burn my stuff? And so it came to them thanking them and begging them to burn after they learned, how valuable it was.
Right.
That's long,
Thank
sorry.
you. Oh, yeah, just a reminder, also try and repeat the questions, I think.
Yeah, sorry.
What's the question? I'll read it. Repeat this question because they won't hear it. Also for Amber, good to see goes demonstrating value. Question on burned area versus detected fire scatter plots. Beers seems to have 2 different clusters. Do you know why? This is from Shobha.
Shobha, I'm not looking at it, but we could look at it together. Everybody heard that question when you said it, right?
Well, actually, I guess I can read it.
Okay. Oh,
Yeah.
oh, okay. So Shobha is asking about the VIIRS clusters between the burned area and the fire detections. And I'm not sure, Shobha, but I welcome that opportunity to work on that together.
Though I think actually depends which product you're using. It can have to do with the pixel sizes of the different instruments. And what you're picking up there are the pixel sizes.
Perhaps.
At least that's what we found when we in our work in the Southeast.
So I have a question for Doug. When you were showing the Pandora measurements for NO2 along with the tracer AQ, and I guess I'm curious from a regulatory perspective, how do you see information from Pandora or Tropomi integrating in with ground-based NO2 monitors for attainment or emissions assessment? How do you see the pieces fitting together?
Right, that's a good question. So far, we have not taken into account Pandora measurements very much within our analyses and in our attainment demonstration. I think a lot of it now is my more familiarity with it is going into the aspect of trying to inform our model performance and trying to see what that column is compared to what our models are showing. There's been some work with Pandora's to attempt to do some profiling to see what the different layers are closer to the surface, so that might be informative for us as well. There's a wealth of data, and I don't know all the best ways to use that. And so hopefully the community can help us as well as state regulators and modelers and incorporate this data more.
And actually, I'll add, so one of the people on our team, Jen Kaiser, she was using a Pandora at the airport. And you could actually, so you could tie it to the ground-based observations, but also capture some of the upper level sources and by looking at the structure in the atmosphere.
Yeah.
So I think there's actually quite a bit of power that can come out of those instruments as we get more familiar with what they can provide and how they interact. And she also compares them to the trope-only observations. So there's a lot that can be done with that.
I'll just quickly follow on. Are there plans for long-term measurements of Pandora? I know you have these intense tracer AQ, these intense field campaigns, but personally, as someone who uses satellite data quite often, it's really helpful to have validation. Are there long-term, do you have any goals to have long-term vertical observation?
In the Houston area, we're now lucky after basically tracer AQ here to continue with Pandora measurements going into the future. I think we're going to have 4 in the Houston area that are going to continue. And that's great. And we'll also have one on the U of H's pontoon boat this summer as well. And so we're going to have some more unique measurements, especially in that offshore coastal area. So yeah, definitely.
Yeah, that's great. I think Ryan also showed a really nice image. Yeah, we're gonna go to him next, I think. But he showed a really nice image showing how Pandora is particularly useful in validation. So next question for Holly or Ryan. Oh, we have to. Oh,
You can read it first.
okay, I'll read it for the audience here. How specifically do you plan to use tempo NO2 data at BOEM? For example, constrain the BOEM's emissions inventory. Could it be used for BOEM's regulatory applications, including enforcement? If so, how accurate would the data need to be? So I'm going to
Did you want to say something first, Holly?
You go ahead.
In terms of the last question, how accurate would the data need to be? I guess I don't really have a number for that, but essentially, yes, the idea is to see what we can do in terms of evaluating the emissions inventory with the tempo or the TROPOMI NO2 data. I think that's more important than the actual amounts of NO2 over the Gulf near these operations, because we saw from the data, NO2 out there is quite low, and it's really just these isolated point sources that we need to evaluate their impact on coastal air quality where populations live. And that's what BOEM's interested in evaluating, determining their impact on coastal air quality eventually.
And I think, sir, could it be used for BOEM's regulatory applications, including enforcement? Currently, there are no monitors offshore in the Gulf of Mexico region, so we are looking at using the satellite data, as Ryan has said, for monitoring air quality offshore. And like he mentioned several times, currently we're just using it. We're going to use it to improve our inventories, validate our inventory. As far as enforcement, our sister agency, BSEE, does all enforcement. So that would be on BSEE if they decide to use it for enforcement or not. But at this time right now, we just want to improve our data. We're not really looking at it on an enforcement side. Any other questions?
Yeah, we have.
Yeah, if you can hear us. There's another one in the Q&A. I think it's for you guys. It's when you evaluate the accuracy of NO2 over the ocean, did you verify that pixel by pixel or the overall statistics? Could you also mention again what you did to truth the data?
Sure. So the truth data is the ground-based Pandora instrument, and we took the research vessel Point Soar out on the water in May 2019 with a sun tracking Pandora, and that was the ground-based truth for that. And really what we did is we just found the pixel, the TROPOMI pixel that the ship was located in during the overpass, and just correlated those one-to-one to see how accurate overall the TROPOMI data were. And both OMI and TROPOMI, we determined about 5% accuracy during that cruise, with some exceptions when it was a little more polluted. But I think that's been shown in even urban areas, that as you get more and more polluted, there can be spatial issues, footprint issues, where the Pandora instrument will measure higher than a satellite, for example. And we may have seen a little bit of that over the water as well.
Okay, thank you, Ryan. Another question from the room now.
My question is about shipping emissions and how much variation there is. My understanding is that different countries have different regulations with regards to fuels that are used in shipping, and I guess ports also have different regulations about that. But I was wondering if you would expect a lot of variation depending on fuel use from different vessels coming in, and if you do, would that show up on satellite remote sensing, or if there needs to be more efforts in terms of monitoring air pollution for trace metals or other air pollutants that might come from these fuels?
And you're absolutely right. There are different regulations varying by country. And there's actually some different regulations in terms of how they do it by state, actually of interest during this period. So at first, I think they had to be hoteling out, so sort of sitting about 20, something on the order of 20 miles is when they had to change fuels and sit out. And that they raised that to, I think, 150 miles. I could be wrong on some of the details of that, just to essentially reduce the air quality impacts. In terms of should they be looking at some of these trace metals, because there are specific, vanadiums, et cetera, that you could be using, that would be great. Not sure when if that would happen just in a practical sense. In terms of using the satellites, I think one of the things we're seeing is that actually from this, we think we can, that the increased shipping emissions can be seen. But that's one of the things we're looking at, is just how well we can see that in the analysis. You have to control for meteorology, and you have to control for all sorts of other things. But we do, a large increase in shipping there, that's a can be a fairly major source. And so that's what we're looking at, is how big is that signal, and can we do that?
Now, I'll add to it too that recent sulfur fuel requirements have been reduced significantly, and that's been seen in observations as well. And so at least in sulfur dioxide, it has decreased in terms of shipping emissions. The use of the automated identification system, AIS, which has transponder receivers for these large vessels, is being used in emission inventories now. And so there's a whole lot of data that's incorporated into that based on what type of ship it is, how loaded it is, the speed of the ship in very small segments. And so that's being used in emission inventories now that are feeding into our models and regulatory applications. And so we're getting better data to estimate those emissions. But in terms of the specific fuel that they're using, where that's sourced from, that's a more difficult question, I think.
Yes.
So I have a question. My question is related to the data. So when you're looking at this surface tool, just I'm curious to know how you can handle the lighting. Comes from lighting. So you can handle that.
Yeah. So how do you handle lightning knocks?
So
Yeah.
we actually do model the lightning knocks. That is probably a weakness. It's in the upper level, and without a doubt, so we see that as the CMAQ is low on some of the upper level NO2. What that does is it doesn't really impact our ability to do the comparison over larger sources being power plants or cities, but it definitely does inhibit the comparison over more rural areas. CMAQ's almost always lower than tropomi. So it's there, and it's a background we don't pick up so well, but it doesn't tend to inhibit our ability to do the comparison over the larger sources. But if we started to look at really small sources, it might get quite a bit more tricky.
I'll add one more thing to that. And lightning knocks is an important source when we're looking at this, but there's also other sources, especially cruise emissions from aircraft. And in a lot of our model simulations, we don't account for that. The emissions are just during the landing and takeoff cycle below 3,000 feet. And so that could be another source of NO2 that could be in the upper atmosphere that's not accounted for.
And not to plug the paper, but actually the results that I showed, we went through that, is that we did include the NOx emissions through essentially the entire flight path over Atlanta, going up to wherever that plane left the domain. So we went well above the 3,000 feet or whatever or 3,000 meters to capture that. And it does make a difference.
Thank you. Yes.
Question for the NASA BOEM folks, but I'm curious, the scope cruise that's planned for 2023, is it also just going to be a Pandora data collection, or is there any surface measurements that y'all going to do with that? And just kind of how long would that cruise be? And is there additional data that BOEM needs to help assess their inventories? I'm working with the University of Houston to do some boat work there, and we're essentially working on expanding our marine capacity. So kind of curious as what the limitations there are.
So you'd asked what basically are the instruments we're going to be taking on the next cruise. So I didn't mention it, but in the May 2019 cruise, we did have surface ozone, NO2, black carbon. We had a ceilometer. We launched ozone sondes off the ship. The Pandora, of course. We had VOC canisters as well, which came in handy near the shallow water platforms. I mean, we captured that big methane spike that I showed, and confirmed that with the VOC canister. Also measured lots of benzene in that plume as well. In a way, we're going to do similar. We're going to have similar instrumentation on the planned June 2023 cruise, and I imagine we'll take a similar path, and probably up to 2 weeks on the water. In 2019, we were out there for 9 days, but we may be able to do up to 2 weeks for 2023. And of course, a key addition would be the aircraft measurements. So that I think will be really nice to have as well. And I think the second part might have dropped out a little bit, but does that answer your question?
Does BOEM have any plans to try and partner with anybody to get additional data more long term besides just the cruise intensive mission?
Good question. I'm not aware of too many long-term programs that take these kinds of measurements. I think there might be something in Long Island Sound. They may be putting a Pandora long-term on a ferry up there, which would be very fantastic measurements, I think. But other than that, no, nothing that I can really think of in terms of long-term measurements such as these.
So this is Holly from BOEM, and we do have a monitoring station on the coast of Louisiana, and we are considering adding a Pandora in that monitoring station currently, and it would be there for 5 years. But it's not offshore, it's on the coast of Louisiana at a high school.
All right, thank you both. Are there additional questions in the room? We have 4 or 5 more minutes.
I have a question. Oh, I'm sorry. Go ahead.
Yeah.
Right, so I was wondering actually about the wildfires. Is there any information on whether the pollution levels are more associated with the area burned or the intensity of the burning?
I think that's a complicated question. And the reasons why is if you have a really big fire that burns a lot of fuel and it's a lot of area and it burns down, these are often injected high. Not only do they train a little bit, they injected high and they travel. So as they travel, then they come down somewhere else. So it's kind of a complicated story. And like we were talking about last night, and I forgot to repeat the question. And the question is about the types of smoke and the amount of fuel and if burned areas correlated to air quality. And I think that if you're looking at PM 2.5, the answer would be likely yes, yes. But if you're looking for health effects, I'm not certain because I think the results are mixed. Like we don't know because we've done a poor job of quantifying fire in the Southeast quite often. And that would be more where we have persistent fires at certain times. So I think that would be the next steps is health assessments and epidemiological studies like people you work with could do. And then what do we do from there? Because we need fire. So what is that balance? Thanks.
Yes, you can go with the last question.
Oh, okay. My question is, you are both looking at CMAQ models and the outcome, and you're saying that we could improve here, and you've insinuated, or you said that you think you know why, both of you did at certain times. So I guess the questions are, when I see the models, I'm like, wow, they're doing a pretty good job. I can see that they could do better, but CMAQ does a pretty good job. So how are you working with people that are running CMAQ runs in order to improve the models using satellite data? What are your ideas for what can be done? I mean, is this complicated? I mean, how do we get that last little feedback to the models?
Wow.
Sorry.
That's
2 minutes.
yeah. Certainly we've used, and this is in TC
TCQ standpoint, I guess, we've used a lot of satellite data to help us characterize our inputs. We've used satellite data to characterize some of our global modeling and determine the performance of that. We've used a little bit of it in terms of doing that for our photochemical models, but not as much. And so trying to make that next step of incorporating some of this data to assess our models and perhaps improve them, I think that's, you know, we're still trying to get there and determine the best ways to do that. Some of the challenges, and we've continued to say this, is using that satellite data and trying to understand what's at the surface. And especially in terms of ozone that we've had to deal a lot with, that's still a difficult thing. And Tempo's going to help us with that and trying to have a more surface layer observation, I guess you could say. Yeah, I guess I'll stop and let Ted.
Yeah, and actually, as you may know, I'm primarily a modeler who's come into the satellite domain. So we do the modeling ourselves. And what you can actually do is go into some of the internals of how CMAQ does transport and look at the emissions and how those compare. So really what I think we're getting at, and you know, talking with Dan and from the presentation, is that this comparison is getting pretty good. You know, there's still some differences, and it's those differences that are now of real interest because that's tied to the uncertainties in the inventory, which is one of the real questions that everybody's asking is our NOx inventory good? Because that's going to be tied to your ozone policies and how well the models do in general. So we're trying to figure out what are, you know, even some of the minor differences. You know, the comparison looks great, but there are those differences, and those differences can be important. And so that's where we are. And you know, in terms of like what we're doing in Los Angeles, they have specific policies in place right at the ports. Are those working? And you can't really, the ground-based monitoring, I'll say it's a bit variable. You know, you don't have as much consistency and it's too localized. So being able to compare CMAQ and the satellites works very well because it's much more of a regional or broader comparison. So it's a better way to do this model analysis.
Thank you.
Thank you.
It's complicated.
Yeah, thank you.
Complicated in the same ways that PM is.
That's right.
Absolutely.
The vertical makes a big difference.
Let's give a round of applause for